Thank you for kind introduction. And first of all, I'd like to celebrate National Day of Glass and International Year of Glass. Congratulations. It's an honor to be here. So today, I'd like to talk about glass window, past, present, and future. Yes, this picture is I think, the oldest glass window, which was found in Herculaneum in Italy, beside Pompeii. So the production date was almost, it is estimated 2,000 years ago, just before eruption of Mount Vesuvius. Since then, I think glass window historically started to be used as an interface between outside and inside the house. The interface allows sunlight to pass through, but keeps rain and wind out. But as you know, the sunlight, with the wavelength spectrum is very broad from ultraviolet to infrared, and its energy is so huge. So in summer, the almost 70% of solar energy penetrates through windows in the house. Probably this is Japan case, slightly different from the European or the US house, but 70% is very huge. So the solar protection is required to control the solar energy penetration. So the coated solar protection glass was developed to control the amount of solar energy penetrating into the building in order to keep the room cooler than the conventional normal glass. So these are the typical transmission and the reflection spectra of solar protection glasses. So please take a look at the left side. The red line shows the solar protection glass transmissions of the solar protection glass. So if we compare with the conventional solar glass, the transmission is well controlled. It means the solar energy can be protected thanks to this configuration, the coating, metal, nitride, and oxide. And the appearance of the building depends on the reflection spectrum of solar protected glass. So we can control the reflection spectrum depending on the configuration of coating structure. And in winter, so heat loss is the big issue for the houses. So this picture shows the historical Japanese house, so World Heritage, Shirakawa-go. I've never seen, but I found this picture. So probably this also the Japan data. Almost half of inside energy escape through window. So the heat transfer management is very much important for winter. So how to manage heat transfer? So there are three typical modes of heat transfer. First one is conduction, and convection, and radiation. This is three important heat transfer modes. With regard to conduction, this table shows the thermal conductivity of several matter. If we compare air with glass, the thermal conductivity of air is much smaller than glass. And in case of argon, smaller than air. And finally, vacuum, it is almost zero. And with regard to convection, the narrow space restricts convection. And the radiation, it depends on the material. If we compare with glass, the metals are much smaller than glass, especially in the silver, this is very small. So thinking of this heat transfer principle, we are developed the insulating glass unit. So we use the double glazing to keep some air spaces, which can create good conduction and convection for the heat transfer. And also we coated metal on the one surface of the glazing, so to reduce the emissivity. Mainly silver metal is used to coat. So this is insulating glass unit low E. Low E means the low emissivity. And the thermal transmittance is evaluated by using the U value, which is a famous number. So when we see the 3 millimeter thick single glazing, the U value is 6.0. And double glazing unit filled with air, the value is 2.9. And triple glazing, the U value becomes 1.9. And if we put the coating, low E coating, U value becomes 1.6. And filled with argon gas, this is low E argon, the number is 1.3, very good. And the current, the cutting edge technology is vacuum low E glass. This U number is 0.4 to 0.7, almost 1/10 of the single glazing. So we can reduce the heat loss from the house. And if we think we'd like to use glass much, much more, but in case we face the trade-off challenges. For example, sometimes we like sunlight as much as possible, but sometimes we don't like overheating, or we don't like glare. Well, we like to use sunlight as day lighting in the morning and in the afternoon, but in the evening, we like to like privacy. So to solve these trade-off challenges, the dynamic control of light will be required. So we'd like to switch the glass. So there are several switchable glazing technologies are proposed. So on-demand switching. So first one is suspended particle device, so-called SPD. So the absorption coefficient of this particle depends on the alignment of particle. When we apply some voltage, the particles are aligned like this. So we can control the absorption coefficient of this glass. This is black and this is transparent. The switching speed of these two phases is several seconds. And the second one is electrochromic device, ECW or ECD. So this, we can utilize the electrochemical reaction. When we apply some of the electric field, the ions are moving. Then the colors are changed. The switching speed of the EC is several minutes, not so fast. And finally, polymer dispersed liquid crystal, PDLC. So this is a kind of a liquid crystal. So we are utilizing the scattering of liquid crystal, white and transparent. This switching speed is very fast, millisecond. And these are the actual application of switching glazing. This is San Francisco Airport, the electrochromic window from View company. And this is office in Brussels, electrochromic window from helium. And these two bottom 4 pictures are in the automotive vehicle. The left-hand side is the suspended particle devices from our company, AGC. And right-hand side is the PDLC, also from AGC. So scattering and transparent, black and transparent, much different. So this is light and heat manageable window. I'd like to summarize this topic. So modern window minimizes the heat loss and increases the comfort of occupants or passengers. So the window contributes to energy savings of building and reduction of greenhouse gas emissions. And in addition to light and heat control, next I'd like to introduce our recent activity for radio wave control. You know the 5G communication system. So this graph shows, This graph shows the mobile traffic trend until 2030. So as you can see, the explosion of the mobile traffic will be happening thanks to the many IoT devices or 4K or 8K contents. So these needs the traffic. So to solve the this traffic demand, 5G communication technology was already launched. 5G uses high-frequency radio waves, such as 28 gigahertz or 70 gigahertz. So in case of high-frequency radio waves, we have several issues. First one is the transmission or penetration issue. So this graph shows the transmittance of building materials, concrete, wallboard, and glass. So horizontal axis shows the frequency, and vertical axis shows the transmittance. For example, in case of concrete, thickness is 30 millimeters, even with the sub-6 frequency, about 6 gigahertz, the transmission is more than minus 10 dB. It means 1/10, 10%. Only 10% can be transmitted. And the 5G 28 gigahertz case, even with wallboard thickness 100 millimeters, the transmission is only minus 6 dB. So huge loss. Among these materials, glass shows very good transmission. But even in glass, if we increase the thickness, the loss becomes bigger. And also, other than the transmission or penetration loss, we have 2 issues. First one is reach. The high frequency radio waves, the reach length of high frequency radio waves becomes shorter with increasing in the frequency because of the absorption by air. And also the high frequency radio wave cannot reach behind the objects due to the less diffraction of these waves. So I mean, if we, this is a 5G antenna, and from this antenna, high frequency radio waves propagate straight, and behind the buildings or behind trees, these shadows appear. So how to improve these issues? So shadow is we call blind zone. Let me show you the illustration. So this is the room of the house, and high frequency radio waves is coming from the bottom side. And as I explained, the window glass is only the gateway to pass through these radio waves. And it propagates straight. So behind the walls, blind zones appear like this. Only the center zone, we can detect the high frequency waves. How to solve this issue? So when we put the repeater inside the room, so this repeater can regenerate the radio waves again. So if we focus the radio waves which received on entire window glass on this repeater, then we can get the good radio waves inside the rooms. So we try to utilize window glass as a lens. So we use the Fresnel zone plate lens technologies. So this lens functionality is generated by shielding waves, which are not the same phase at the focal position. So like this kind of the concentric circle. This is very simple, the probably structure. And we made this structure. So this is transparent. We call metasurface window. So probably it is very difficult to see. So I also put the non-transparent type picture. You can see that this small unit. So this is the unit cell, the 3.5 millimeter square, and this is the kind of metasurface structure. So this unit can deflect only 28 gigahertz band. So this is the dimension. So this black part is shielded zone. And the shielded zone was made using this unit cells. And next, we demonstrated the area trial using actual environment. So we put the base station, which is 28 gigahertz. And we put the window here, and we measure the power using power meter. You measure the intensity of the radio waves using power meter. So please take a look at the left-hand side. There is normal window glass. As I can explain, the window is only a gateway to pass through. So this zone behind the window, this is very good electric wave environment, but the blind zones appeared like this. So we put the repeater here, and also we use the metasurface lens technology. The environment is much improved like this. Very good.
Of course, as soon as they change the frequency.
So this is summary of my talk. So glass window has been historically contributed to human life as an interface which allows light and heat to pass through, but not rain and wind. And modern window manages light and heat, so it can contribute to the comfort of the occupant and also contribute to reduction of GHG emissions. It is very important. And also it becomes the best gateway and interface for 5G communications. So we would like to say glass window evolves continuously with development of a sustainable society. And this is last slide. I would like to appeal the special exhibition, the identity of the glass, which is now start at our new research facility, so-called AGC, Yokohama Technical Center. Just started in this April, and I would like to extend this period until the end of this year because the closing ceremony will be held in December. So the concept of this special exhibition is rediscover the attractive facets of the glass in a way of storytelling, terror, prayer, cave, uncertain boundary, light, and tree. So please contact this contact address. So please, you have this leaflet. We have some contract mail address. So please contact us to join us. Thank you very much.